Hi everybody, this is Mr. Diehl and I'm going to be going over multiplication. So to review real quick, addition is a big part of multiplication. So what we're going to be doing when it comes to multiplication, which definitely sounds like a big word, but it's honestly not that bad. What we're going to be doing is we're going to be basically adding the same number repeatedly. So for example, instead of 2 plus 2, we're going to do 2 plus 2 plus 2 plus 2 plus 2, and so on and so forth, right? So, we on the same page? Good. Um, so, let's go ahead and do a very, very quick do now. We'll do it together since this is a presentation. So, we're going to do a very quick do now. Number one, Johnny has 12 apples. So, we have 12, but he gets 12 more. So, we're going to be having another 12, correct? So 12 plus 12. How many apples does Johnny have? If your answer was 24 to coincide with 12 plus 12, that would be correct. Now, Pippin has 2 rings. So Pippin, he's got 2 rings. Then he wants to have 2 more. Then another 2 more. Then 2 more on top of that. Check that out. That's quite a few 2s, right? So how many rings does Pippin have? Well, we can go over the answer with 2 plus 2. So 2 plus 2 is 4. Then plus 2 more would be 6. Then plus 2 more would be 8. You with me so far? Good. Very, very good. This is where multiplication is going to come into effect because we don't have to write 2 plus 2 plus 2 plus 2 plus 2 plus 2 and go on and on. We can actually do this a much, much simpler way, and I'm going to show you how to do that. So multiplication, as we said, is the addition of a number repeated, right? And so, for example, 6 plus 6 plus 6, just like how we had with Pippin, 2 plus 2 plus 2, so on and so forth, it's a form of multiplication. But the important thing that we need to keep in mind is the amount of 6s that we have. So how many 6s are there? Well, we have 6 plus 6 plus 6 plus 6. So we got 1, 2, 3, 4 6s. 4 6s, right? So what we're going to do is instead of doing 6 plus 6 plus 6 plus 6, what we're going to do is we're going to take 1 6, put an X, 4. So we have 6, and this is called a times symbol, 6 times 4. And these two are equal to the same. So just to go over it real quick, what do we think 6 plus 4, or 6, sorry, excuse me, 6 times 4? What do we think 6 times 4 is going to be? Well, we could add 6 plus 6 plus 6 plus 6, and then we would get the same answer. So what is that? 6 plus 6 plus 6 plus 6. Well, if your answer was 24, that is a very, very bad 24. Let's redo that. If your answer was 24, you would be correct. So 6 times 4 is really just 6 plus 6 plus 6 plus 6. You with me so far? Good. Okay. So moving on to the next slide here in a second. Let's try it together. So 6 times 2. Well, what's 6 times 2? Well, we already established that 6 times 4 was 6 plus 6 plus 6 plus 6. So let's do 6 times 2. It seems a lot shorter, right? So it should just be 6 plus 6. So what's that? 12. No problem, right? Now let's do it here. We got 10 times 3. So that would be 10 plus 10. And then, yeah, plus one more 10, right? Good job. And what does that come out to be? It should be 30. Good work. So there are actually a few special rules in multiplication that are a lot easier on your brain. So let's go ahead and try out the first rule here. So it says in the cases where a number is multiplied by 1, the number will always be the same. So let's try it. So we got 8 times 1. We have 8 times 1. So what would that be? Well, it would be 8. Oh, oh yeah. You see, there's not another 8. There's only one 8. So that means the answer is 8. There's nothing else to do. You got it. All right. So what do we think now if the number is going to be multiplied by 0? That's interesting, right? So we would have 4. Oh, but wait, we wouldn't even have the 1, right? So there wouldn't be a 4. So what do we have? That's right. If you thought 0, you would actually be correct. So anytime you see a 0 in a multiplication problem, the answer is always 0. Doesn't matter. It could be 0 times 0. It would equal 0. It could be 0 times like 1 million. And it would still equal 0. Good. You with me so far? Awesome. We're almost at the end of this lesson. So let's go ahead and move on. Once I got the eraser here. Wonderful. Okay. So we got one more special rule that we're going to talk about. And that is what we like to call the... So it's actually called the commutative property. And that is a big word. So we're going to go ahead and write that out. Sorry, that is not an A. Give me a second. Commutative property. What does that mean? Well, it means that if you have 2 times 4, so what we'll do is we'll have 2 plus 2 plus 2 plus 2. So we got 4 2's, right? And then we have 4 times 2, so that's 4 plus 4. Well, let's take a look. What does 2 plus 2 plus 2 plus 2 equal? 2 plus 2 is 4. So 4 plus 2 is 6 plus 2 is 8. So what do we got? 8. 4 plus 4, that should be a little simpler. We got 4 plus 4 more, that's 8. Oh, so they're the same, right? Well, the commutative property says that that 2 times 4 and 4 times 2 will always be the same answer, because in multiplication, it doesn't matter if one number is on one side or if it's on the other. It does the same thing. So with that in mind, do 12 times 4 and 4 times 12 equal the same thing? Let me know. Let me know what you think. I'll let you do that one in your head. So, since this is not a real lesson, I will just show the final slide. It's nothing special. It's just individual task work. Yeah, down here we have 0 times 0, which is 0, just to reiterate the rule from before. And then we have 4 times 3, just as a basic problem. And then we got 5 times 5 to practice multiplying numbers that are the same. So, yeah, it's